Okay, so you've completed the simulation, and the simulation walked you through how covalent bonding forms, and a little bit about the reason why, and it talked about some things about lowering potential energy and all those things that might have been a little confusing, but regardless, we're going to kind of walk through it a little bit more in detail today. So, some things to remember is that we're talking about covalent bonding. So, with covalent bonding, we have a periodic table, and that tends to occur. Covalent bonding really only occurs with metals and nonmetals, right? And so sometimes hydrogen is included in that. The number of valence electrons are important, and there's actually no transfer. It's an initial sharing. So let's go and talk a little bit about how this works. So first of all, over in the first box, over on the left-hand side, I have two hydrogen atoms that are nowhere near each other, and they both are showing that they have their one valence electron. So remember that hydrogen has one valence electron, and if we draw its structure, its Lewis dot structure, we would have something like that, which is very similar to what's drawn above. Also, if we were to draw some type of a modified Bohr model, it would look something like that. So what ends up happening is that as long as these two hydrogen atoms are not near each other, they're not going to really be attracted. But as they get closer and closer to one another, we have to remember a couple of things about the structure of atoms. So if I'm going to look at the structure of an atom in the nucleus, okay, the nucleus has a positive charge, okay, and the electrons have a negative charge. And if they are surrounding the nucleus, in a neutral atom, they are sort of canceling each other out. But the issue is that if another atom with another positive nucleus, like this, comes into contact with another atom, or with the electron, something like this, what's happening here is there is an attraction between the positive nucleus, I don't like that, between the positive nucleus and the negative electron in one atom, and there's also an attraction between the positive nucleus and the negative electron in another atom. So what I'm getting at here is that when nonmetals come in contact with one another or come near each other, the nucleus of atom A is attracted to the electron of atom B, and the nucleus of atom B is attracted to the electron of atom A. And as a result of that, the electrons tend to share the same spatial area. So instead of being flying all around like in the case of the first box over here, where I've got an electron way out here and an electron way out here, what ends up happening is that those electrons really get funneled into the space in between in between the two atoms. And when that happens, the atoms form a bond, and that bond is called a covalent bond. Now, the thing that you need to remember about covalent bonds is that they only occur between nonmetals and nonmetals. You will not find a metal participating in a covalent bond. So, moving forward, the definition of a covalent bond is, let's see, definition of covalent bond is the attraction between two atoms that are held together by their mutual attraction for their shared electrons. Okay, and this is also the definition that we would work with when we were talking about using a, when we talk about a molecule. Remember yesterday we talked about the idea that a molecule is a structure that forms when two or more nonmetals bond together. It's nonmetal and nonmetal. Okay, sorry, I'm not sure what happened there. So the next thing I'm gonna do is I'm gonna take my hydrogens and I'm gonna, or my electrons rather, and I'm gonna put them in between. I'm gonna put them in between the two atoms in question. Then what I'm gonna do is I'm gonna draw a circle, and I'm gonna use, let's see, green for my circles. So I'm going to use a circle to indicate that those electrons are being shared. And then the last thing I'm going to do is I'm going to replace my circle and the two electrons with a line. So one line equals two electrons. Oops. In a bond. And that's really important to know. So, that's kind of the long and the short of it, so we're going to go through a couple of examples. Sometimes, though, as one of the examples, we can talk about the idea that some atoms share more than two electrons. And so in these covalent bonds, are known as double bonds. Which really would indicate that there are four shared electrons. And they're also known as triple bonds, in which case you would have 6 shared electrons. So let's do an example associated with that. So I'm going to use oxygen, and I know that oxygen, according to the periodic table, has 6 valence electrons, and the other oxygen also has 6 valence electrons. So what I'm going to do is I'm going to draw the structure for that. So that would look like this: 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay, so now what I'm going to do is I'm going to take a look at those and see how I can get the pairs of electrons close to each other that need to share. So what I'm going to do is I'm going to take them and draw them closer to one another. Ooh, that's too big. And then I'm going to take and draw a pair of electrons here and a pair of electrons here. So those are my two that are going to share. So really, in reality, I'm looking at this guy and this guy, and I'm looking at this guy and this guy. So now I'm going to circle that to indicate the bonds. Now I have to make sure that I have the rest of my electrons that should be there. So 2, 3, 4. Okay, and then 1, 2, 3, 4. Okay, so now I've got a double bond situation here where in this case each atom has 8 valence electrons. So oxygen A has 8 valence electrons. Now because it's got the 1, 2, 3, 4, 5, 6, 7, 8 that it's sharing, and oxygen B has 8 valence electrons because of the 1, 2, 3, 4, 5, 6, 7, 8 that it's sharing also. So that means that the atoms both have fulfilled the octet rule. So the last thing we have to do is we have to go ahead and clean our structure up a little bit by drawing lines, because each line represents 2 electrons that are being shared. And then I'm going to put my remaining electrons that were pairs on the atom here. So that's the first part of it, and that's how the multiple bonds work. Now, I've kind of shown you a bunch of examples where we've used the same atoms to bond together, but with covalent bonds we can do different types of atoms. So we can do things like carbon and oxygen, or carbon and hydrogen, for example. But in this case here, I'm going to take a look at what I got. I have one carbon atom, and I have 2 oxygen atoms. I know that oxygen, according to the periodic table, has 6, what is going on here? Oh, I see. Has 6 valence electrons. And I know that carbon, according to the periodic table, has 4 valence electrons. So the first thing I'm going to do is I'm going to draw my carbon. So carbon and his 4 valence electrons, 1, 2, 3, 4. I'm going to draw my oxygen with his 6 valence electrons. 1, 2, 3, 4, 5, 6. And another oxygen with its 6 valence electrons. 1, 2, 3, 4, 5, 6. Now, I'm going to start pairing up electrons that I can pair up. So I'm going to take this guy here, and I'm going to take and draw a circle around those 2. And I'm going to take this guy here and draw a circle around those 2. So now I've created 2 bonds in between carbon and oxygen. Oxygen looks to me like it has 8 valence electrons because it's got 1, 2, 3, 4, 5, 6, 7, 8. Nobody else is satisfied at this point. So now I'm going to go ahead and I'm going to draw, or I'm going to identify if I can take those 2 electrons and make a pair, and maybe these 2 electrons and make a pair. And now the oxygen on the right hand side has got 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it's satisfied with its 8 valence electrons. And carbon now has 1, 2, 3, 4, 5, 6, 7, 8. It also has 8 valence electrons because it's sharing lots of electrons. So when I go to draw the final structure here, I'm going to draw oxygen and carbon and oxygen, and I'm going to show that I've got double bond in between both of my carbons, or both of my oxygens and my carbon, and I'm going to complete the structure by finishing up with my 8 valence electrons. And so now everybody's satisfied and everybody has 8 valence electrons. Note, the one thing that I haven't talked about here at all is charge. So in covalent bonding, there are no charges. Okay, so that's another thing we need to keep in mind. All right, so your homework tonight is to do worksheet number 4, which is covalent bonding, and I believe it's a 2-sider, so good luck.